So this is what I said about this diagrammatic representation, which shows the presence of these three pairs of alleles, which are located at a three different loci on the chromosome. Okay, and so this produces, okay, DED, it produces D antigen. Okay, but as I said, if it is present in recessive condition, small d antigen is not produced, and CC antigen is produced in this type, and EE, this genotype produces EE antigen. Okay, we shall discuss now about what is Wiener hypothesis. In Wiener hypothesis, he proposed that the existence of 8 alleles, okay, 8 alleles or 4 pairs of alleles, okay, at a single RH locus. So as per race theory, that is as per Fisher and race hypothesis we discussed, there are 3 pairs of alleles, but as per this Wiener hypothesis, he proposed that there are 8 alleles at a single RH locus. But in Fisher and race theory, we discussed 3 pairs of alleles are situated at different loci. Okay, but here, as per Wiener hypothesis, he found that 8 alleles or 4 pairs of alleles are present at a single RH locus. All genotypes carrying a dominant R allele, that is R1, R2, R0, or it can be called as RO also, then RZ. So all these dominant R alleles produce RH positive phenotype. Okay, all dominant alleles, capital R1, capital R2, all these, okay, they produce RH positive phenotype, and double recessive genotypes like small r, small r1, okay, this is recessive. Okay, so these recessive genotypes will always give rise to RH negative phenotype. Okay, so this is about, it's a very simple information, you can easily remember, but the difference between Fisher race hypothesis and Wiener hypothesis you should understand. Okay, you go through the information again, you can easily understand. Okay, so we shall move on to the next one. So what will happen if there is incompatibility of RH factor? Okay, so incompatibility of RH factor, it leads to disease, okay, an abnormal condition called erythroblastosis fetalis. Okay, we'll discuss about what is erythroblastosis fetalis. So RH incompatibility has a great significance in childbirth. We discussed already, when RH negative person is exposed, okay, when the blood of RH negative person is exposed to RH positive blood, then some complications will arise. Okay, so we are going to discuss about what are the complications due to this RH incompatibility. So if a woman is RH negative, okay, a pregnant woman who is RH negative, and the man is RH positive, okay, husband is RH positive, wife is RH negative. In that case, the fetus may be RH positive, because fetus or the developing embryo may have inherited this RH positive from RH positive father. Okay, so mother is RH negative and the fetus is RH positive. So what happens is, the RH negative mother becomes sensitized. Okay, RH negative mother becomes sensitized by carrying RH positive fetus within her body. Okay, so both are different. Blood group is mother's is RH negative, fetus is RH positive. And due to damage of blood vessels during childbirth, okay, during childbirth, blood vessels damage. So what happens is, the mother's immune system recognizes the RH antigens and gets sensitized. Okay, mother's body understands the difference in the RH, that because the fetus is RH positive, so mother's body is sensitized and recognizes RH antigen of the fetus. Okay, the sensitized mother produces RH antibodies. So antibodies are produced when for antigens. Okay, it is called antigen antibody reaction. Whenever antigens are entering into the body, immediately our immune system produces antibodies. So this is what is happening in this case also. Mother's body produces RH antibodies in response to RH antigen of the fetus. So what happens is, the antibodies are IgG type, that is immunoglobulin G type. IgG refers to immunoglobulin G type. So it's a protein, okay, kind of protein, but antibodies. So all antibodies are proteins. So this antibodies, they are very small and they can cross placenta and enter the fetal circulation. So the antibodies produced by the mother's immune system, this IgG, can easily cross placenta and enter the fetal circulation. By the time mother gets sensitized and produce anti-D antibodies, the child is delivered. But by the time the mother's body recognizes this antigen, and by the time mother's body, that is immune system, gets sensitized and produces antibodies, but by the time the child is delivered, so no harm is done to child, okay, during this first pregnancy. So as I said, usually no effects are associated with exposure of the mother to Rh positive antigen during the first childbirth. Okay, so during first childbirth, when mother is Rh negative, okay, usually no effects are associated with exposure of the mother to Rh positive antigen during the first childbirth. Yes, mother does not, that is nothing can happen, that is nothing harms the mother and the child, okay, during the first childbirth. Okay, but subsequent, that is okay, in the second pregnancy, so Rh positive children carried by the same mother, okay, for the second time, when the same mother carrying the second child, so and this is also Rh positive child, so may be exposed to antibodies produced by the mother against Rh antigen, that is during the first pregnancy, are carried across placenta into the fetal blood circulation. So please try to understand, that is the antibodies produced by the mother during the first pregnancy in response to Rh antigen of the fetus, okay, now present in the body of the, or in the blood of the mother. Okay, so these antibodies move, okay, or they are carried across the placenta into the fetal blood circulation. So this is what is happening during the second pregnancy. So what happens is, this causes hemolysis of fetal RBCs, resulting in hemolytic jaundice and anemia. This condition is known as erythroblastosis fetalis. Erythroblastosis fetalis, or also called HDN, that is hemolytic disease of the newborn. Hemolytic disease of the newborn. Okay, so I am trying to explain again. So mother is Rh negative, and the child, that is the fetus or the developing embryo, is Rh negative. Rh positive. Mother is Rh negative and fetus is Rh positive. So in order to, that is the immune system recognizes, the mother's immune system recognizes the Rh antigen of the, that is Rh positive fetus have Rh antigen. So that Rh antigen of the fetus is recognized by the mother's immune system. So antibodies are produced. But before the antibodies produced by the mother's blood, before it enters into circulation, blood circulation of the child is delivered. So nothing happens during the first pregnancy or first delivery. But in the subsequent pregnancies, when the mother carrying again the positive, that is Rh positive child, that will affect the child. That is, what happens is, the antibodies produced by the immune system of the body that will enter into the placental circulation or fetal blood, through placenta fetal blood circulation. Antibodies produced by the immune system of the mother enters through the placenta into the fetal blood circulation. These antibodies will destroy, okay, these antibodies will destroy the RBCs, resulting in hemolytic, lytic itself refers to destruction, hemolytic jaundice or anemia. This condition is known as erythroblastosis fetalis, or also called hemolytic disease of the newborn. Okay, that is, in short, it is called HDN. Okay.